Okay guys, so in this video we're going to talk about something that is very close to my heart, and that is integrations. So let's get into it. So basically what we're going to cover today is one of the biggest problems with integration-based applications, a possible way to solve it, one that I've found to be very powerful and expressive and fairly easy to work with, and the end goal, basically. So let's start at the end. So when it comes to integration-based applications, one of the things that you will have to accept is that you are basically trying to achieve something that is almost impossible to get nice, which is that you have two different systems built by two different organizations with very different ways of structuring code and different domain logic and things of this nature, right? And now you want them to connect. You want them to communicate somehow so that they produce some value for someone outside in the cyberspace of the world, right? And that is extremely tricky because just the fact that you have two different systems that have these different perspectives and different needs makes it all that much trickier to actually connect them. And the worst part is that the more different the organization is from your own organization, the harder it might actually be for you to make that happen. So if you've created, let's just say for the sake of argument, you created this amazing little application that does something great, you have a standard API, you built it just so it works perfectly, and then somebody comes into your office and says, hey, you know what, we want a direct integration to your system. Can you provide that? Now, this is where it gets tricky. And the reason why it gets tricky is because the end goal for you, the thing that you want to achieve as an organization, is to have a standard API. I'll give you an example. Twitter, Google, Facebook, all of these big, large organizations, they have a standard API. This is the thing that they ship to everybody. Everybody uses the same API, everybody does it the same way. The reason why this is the end goal for you is because that is the least amount of work for you as a company. However, there's a difference between you and Google, and that is that you are not Google. You are not in a position very often where you can just say that, hey, we have this standard API and you're just going to have to, you can use that, right? Because if you're lucky, the person or like the organization that wants to integrate to you, they're going to accept that and they're going to say, yeah, this is what we want. Let's do that. But if your customer is a more conservative or like an organization that is less flexible, it's very likely that they will say, well, I know this is going to be too much work for us. We're not, we need you to change some stuff. And this is where it gets really painful, because now you have to make the decision. Is it more important to you to sign the contract, or is it more important to you to actually solve this? Now, I will just tell you from experience, 99.9999% of the time, the business department in your company are going to say, of course we can fix it. Let's just talk to our developers and we will make some customizations just for you so it works the way that it suits your systems. Because, hey, we are a startup, or we're this and that, and we are flexible and we're agile and all these cool things, right? And that's the thing when it comes, it doesn't have to be B2B integrations, it can be pretty much anything. Like some of the common problems that you will face is like you have, like, because this is where it gets tricky, because now basically what you've done is that the system works exactly the same way for everybody except for this customer. And I can promise you that then there's going to be another customer, and then it's going to work a little bit different for that customer. It's going to be a little bit different for them as well. They're going to do some custom stuff, somebody else is going to do something custom. This is like everyday stuff for most developers who work with an international product, where you have multiple customers integrating or using the same platform. It's like, it's so normal that it's almost painful in enterprise. So the problem here is that apart from the more custom logic your customer wants, the more permutations of testing you have. That's a big problem for you, because every time you add a new customization, you need to test that case as well. Every deviation in network interface is another set of documentation that you need to maintain, because remember that customers are expecting things to work in a certain way, and if they have custom stuff, you need to make sure that you're maintaining multiple instances of the same documentation. As I said, in a perfect world, you can just tell them all, we're going to use the standard API, and they're okay with that. But you're going to find that quite a lot of the time, that's not feasible. If your system depends on calling one of the client services, you are at risk of downtime. So another thing that you need to consider is that Some customers will actually force you to call their systems in order for them to be able to grab the value that you are providing. So, and like the last thing that I just at the top of my head is to say that, all right, if you mix customer logic from different clients, it's very likely to cause regressions. As you can imagine, if you have a bunch of different clients sharing the same code base, you're also in a very risky position that, all right, you change something for customer A, and then you forget about customer B, and now their interfaces are broken, and then you have a regression. So the end goal is to, of course, have the least amount of permutations. But when you can't do that, I will show you now the way that I've found to be the most effective to dealing with this sort of problem. And that is basically the configuration approach, a runtime configuration approach. So let's have a look at that. First and foremost, let's look at our server here. It's just this little server here, but there's a little bit of a difference here. We're actually logging out something. We're saying that, okay, you can see here my logs here, loading routes for my bank, active client ID, my bank running on port 3000. All right, so I'm logging out some information here that we will touch on in just a moment. And then here's my application. So the application that you and I have built here together, our super awesome product that we are offering to the world, is a report system where basically this whole system is built around that. All right, someone sends us their report, whatever report it is, and then we have this amazing service called process request, or support service that processes the request. And this is a long running operation, of course, because a lot of people have different types. They send reports in bulk, right? So they might have thousands and thousands of files of data that they want to be processed into some very nice format that we're going to be able to provide to them at a later time with the GET endpoint. That's all we're going to do, right? So that's the basics of it. And here is how we instantiate our services. Let's actually go back to this one so we do get a good look at these. This is just a basic Express application we instantiated. We are accepting JSON as input. We have this thing called use middleware, so we'll touch on that in just a moment. And then we have some stuff that's happening over here. We're not really sure what that is just yet, but we'll talk about that as well. And then we have some error handling. And this is the entire thing. So I'll just very short circuit us to see these services, and then I'll show you this report service, which is where we're going to spend quite some time as well. And then we have a report. This is just a basic data structure where, all right, we have a report status that can be in different states. It can be scheduled, it can be processing, it can be done, it can say that processing failed. So that, because this is a long running operation, so they push a lot of data to us. We churn through a bunch of data. It might take several hours to do that, and then they can retrieve the state of what the report is, like the state of the report. And here is the interface for a report. That's all. Like, it's just a little bit of data. And then we have like just a little client ID, which is just a type alias. Cool. So what's the problem here? Well, the problem is that we're going to play with a scenario. We're going to play with a scenario that, all right, we made this awesome, generic, super amazing product here that does this report thing. We're accepting JSON like pros, and people are pushing stuff, and we're like, yeah, this is awesome. And then Spotify comes along and says, hey, you know what? We really like your product. Could we get like a custom integration to your system that like where you promise, like we have an SLA of some, or SLA, which is a service level agreement that we state that you're going to provide us with support services and you're going to guarantee uptimes and stuff like that, because we really like your system, but we want to make, we're a big customer, right? We're a big company. We want this to work all the time, and we need someone on staff if something goes down. And you go, yeah, of course we can fix that. So luckily enough, Spotify, they're not so, like, they don't really have much in terms of custom requests, but they do have this, like, we have this idea now that, all right, so we have one standard product that we're just offering to a bunch of people, which is like the base API. But then Spotify, I mean, we need some way of knowing what Spotify is using and what everybody else is using. And a very simple way to do that is to provide this configuration system. So as you can see here, basically what I did was, and in this case, it's the instance is logging very clearly out that I am running on my bank, which is something we're going to touch on in a moment. But by isolating the client-specific logic to Spotify into a configuration of some sort, or like a separate entity, or a separate directory as we're doing here, I have now been able to say that, all right, so I'm going to spin up 2 instances, and we're going to have some type of nice load balancer or something in front of that, and we're going to route traffic. So the only thing I have to tell Spotify is to abide by this configuration interface, and here is the configuration interface. So I have a bunch of configs here, which is the thing that we're going to reference in our application, and then we have like the actual implementation. So all we have to say to them is that, hey, you know, you're Spotify, so if you just need to include this header, which is X client ID, and then in that header you need to just specify what client ID you have. That way we can know who you are. That's it. So by doing this, I can now, in the load balancer as it comes in, because I have multiple instances of this application running, I can say, oh yeah, this client ID, it says Spotify here. Okay, then route it to the Spotify instance of my application. So if we have a look at my configurations here, you can see here that in the dev configurations, I have the client ID set to Spotify, and in production, it's also Spotify. So it's very simple. This is nice, because now we can have one instance, which is the thing that is just generic that all the other people who are not Spotify are using, and then we have one for Spotify. That is, we might be allocating more resources, we might have certain uptimes, we might actually pay whatever cloud provider we're using in order to store our information a little bit extra to make sure that this is really a smooth thing, because Spotify is paying us some very nice licensing fee or something like that, right? Cool, we're happy. And then Google comes along and says, hey, you know what? We really like your service as well. I mean, you have Spotify there, but you see, the thing is that we have our systems. They work in they have a few specific quirks, and so we kind of need a few extra things. And then your developers are going to say, oh, okay, it's kind of. We already have one permutation, so it would be nice if we could just use the standard API, and then your sales departments kind of go, don't listen to the dev engineers. Of course we're going to do this. I mean, if you want a custom deal, of course we're going to do a custom thing for you. And Google says, yeah, awesome, we're going to send over the specs, and this is what we're going to need from you. So in Google's scenario, they have a similar setup. So we have, we create a developer and a configurations system. And here we have Google's configurations, and in Google's case they have something they call a service ID and a service ID header, which is just this thing that they tell us that, oh yeah, whenever you respond to us, we just need you to include this information. Because this is how we identify that you are like a green-lit project that we are allowed to take responses from, or something like that. We're just going to funnel you through our systems. And they also say, and we also want a health URL, because we want an SLA with you as well, but we want to make sure that we can ourselves check the health of your system. So, all right, so now we have a URL, and we need to add a custom route of some sort for Google. Cool. So here is our health URL. And here's our prod configuration, which is just, all right, so they told us that, all right, so every response needs the service ID header, which is this thing here, and it needs to contain this value here. And then we include some routes, the health URL and the client ID, and it's the same thing here, and the client ID is just Google. So that's it, right? And here's our custom routes. So we create this custom route, we create a router, and all it's going to do is that this is just what they're going to call in order to ping that, hey, the service is up, right? All right, so now we have a custom thing, right? The first real issue where we're actually going to start to feel the permutation start to come in. And this is where we want to look at our application here. So as I said here in my comment, the goal here is to delay the specificity as much as humanly possible. You want to keep things as generic as long as possible until you reach a point where the permutation needs to happen. So when we're talking about it at the service level, using something like this where you actually pass in the whole request and the response to some type of service that lives on the top level is the way to go here, because you don't want to break things down too early. We'll look at that in just a moment. And then we have something like here, which we're going to look at, like middlewares, common things that needs to happen to the request and the response before we actually reach the point where we are, before we actually are done with the request. And here's the thing that we were looking at earlier. So now we have conditional routes that we need to build when we actually set up the instance. So what we're going to do is that we're going to check the active client ID, because we want to be able to split this box. So we want to have another instance. Remember, now we have 3 instances. We have one instance for the normal, like for everybody else, one for Spotify, and one for Google. The reason why we split it is, as I said, because you might have different agreements for different customers, and that way just creating multiple instances that they can have as dedicated services is a fairly nice idea to keep with you. You can combine them all into one instance, but this is a little bit more specific, or like you're making sure that there's a very good cutoff between the concerns of each party. So we're checking the client ID, like the active client ID, and then basically we're just checking, is it the client ID of my bank? Nope. Or are we going to go further, and we're going to say, is it Google's, like is it the client ID of Google? And then we log out what route we are actually going to load. And in this case, we're just going to include the routes that are for Google. And that's pretty much it. So this is the first permutation, but what's nice about using it, the reason why it's so useful to have this concept of a client ID and an active client ID when we are actually working, is that we can actually just use a switch for all the permutations. We don't have to get fancy with a bunch of custom logic. We can have a very clear separation of concerns. It's just a case matching where we can add one case for each permutation. This keeps our code fairly simple, because the only thing we care about is the ID of the client that is going to contact this specific server. That way we can always be sure that we're mounting the correct stuff. Because what we really don't want is, if let's say we have a bunch of, if you by mistake you start mounting routes that shouldn't be there, then you might actually find yourself in a situation where you're exposing routes that shouldn't be in play for a specific client. Cool. So apart from that, we were saying that we had some processing to do on the request as well. So if we just close Google stuff here and we have a look at there it is, libs. So here we have some middlewares. So let's have a look at these middlewares. So I have this little middleware includer here, which is just going to expose all of these middlewares. And we can just actually look at like the basic one first. Like this is just something that is common for everybody. It's a middleware that just checks that, hey, there is because when they want to get reports, we want to specify a range. They're going to get reports from one date to another date. So this is what this basically does. It just does some basic validation on the input. And then we have the client validation middleware, which is just going to check that there is a header that we were saying earlier. We ask everybody to include a header, and that has a client ID, and then we just make sure that the instance that you are connecting to is the thing that you're actually accessing. Like you're allowed to, the active client ID for this box is the correct one, so we're not by mistake letting Google connect to Spotify's instance or something like that. And then we have the header middleware, which is a very common thing. So you have, as we were saying, there is some need here for custom headers. And then basically what we do is that we check our configs. We get out the configs for all the permutations. In this case, we're just going to focus on Google. And they said, as we said, they were saying, like they need us to include a header on the response, which is super common. And then we do. Like we have this middleware that's just going to check, hey, is this Google? All right, if it's Google that is connecting here, we're going to set the service ID header to the service ID value in the response, and we're just going to send that back. And that's pretty much it. So now we have, in a fairly clean way, added like custom logic that will cater to Google without breaking for Spotify or the regular clients. And the reason I strongly urge you to think about this in the terms of, all right, you just care about the incoming client ID, and then you switch on that client ID to expose, like to figure out what the permutations are going to be. And by just using switch cases like this and putting a log statement every time you hit a permutation step, it becomes very easy for you to follow along in the logs what the flow of all the events that have taken place. And one other thing that becomes very powerful with this is that when you're writing integration tests for your system, you can basically create usage profiles where you can say that depending on how complicated your system is, you can create entire books of or entire suites of tests that just assume that like where you create a request that is meant to go through a certain set of steps, and then you can just assert that every step of the way you're hitting the correct permutation in your flows. This becomes very easy to test. Remember, we don't want these permutations, but we can't stop them because sales are saying yes to everything that the integrating party is asking for, and there's no way for us to stop it, because if they say no, we're not going to get the customer. So we need a way to, in a sustainable fashion, scale the system to a large degree. And we can't just create multiple versions of the same project, because then it's going to be impossible for us to synchronize all of that code. We're just going to have a bunch of duplication. So the best way forward for us is to have a system that just takes a configuration that tells it what the state of the system should be at any given time. Finally, we have My Bank, and now it's getting really hairy, because My Bank, they're a super old bank. They have not, like, they're using COBOL still, and like their systems are super old, and they're a very slow moving organization. They say, yeah, we really want you to integrate to us, but you know, the thing is, we don't really have like a lot of developer velocity, so we're going to need you to do a lot of stuff for us. And they tell us, yeah, we have our own system, so we can't just push data to you like this. You're going to have to go and get it yourself and stuff, and we're going to have to ask you to go through our security song and dance and like get access tokens and all this stuff. And you know, the developers are just kind of go, oh, this is going to be a hassle to maintain. And then they show the money to the sales department, and the sales department goes, yeah, of course, for that price, we're going to implement this. Don't worry about it. And there we are. So here, like, I strongly urge you that this, like, having this idea of splitting out configurations and like specifics to each client into their own directory like this, and like creating a little readme where you explain I like to lovingly call it isolate the madness, because permutations and custom code and like all of these deviations, it becomes madness the larger the system grows. So if you can isolate that madness the better, and explain it it's a very good thing. And here we have our index, and let's look at My Bank configuration. And here you see that, all right, so they have something they call a request code, and they have a service ID just like Google, and then a header, health URLs, and they have something else where for some odd reason they want this header too. Yeah, exactly, like request arrival header. They want to know the date of when the request came in. And then they have an access token URL, because as we were saying, they need us to contact their URLs, like their system, in order to get their reports. And of course they have multiple reports. They have one for an endpoint for XML reports, one for JSON, one for docx, and they have their own routes. And one more thing to add to this little shit sandwich that we got in our lab is that, you know, there are different clients when they call to get their reports. Sometimes they just want this response to be in base 64 for no reason. You just ask why, and they say, no, we need it in base 64 because that's the way that system works. And that means that now you need to figure out a way to respond to a client with base 64. So this is where we have another layer of permutations, and some people will think, all right, we'll just create a different URL for this specific request. And you could do this, but I highly urge you not to, because the problem grows exponentially the more URLs you have, because then you need to basically have one URL to connect to get base 64 and get the response in base 64. You need one for JSON, and they might want XML in the future. It becomes kind of ugly for you. They want the same functionality, but they want different responses. What you basically want to express is that there is a custom behavior to this request, and sometimes it's going to be one thing, and sometimes it's going to be another thing. And this is where something that I call request codes comes into play. And basically what that means is that you have a second header, you have a client ID header that tells you who it is that is contacting you, and then you have a request code. And in the request code, or request ID, call it whatever you want, you create a mapping between the permutation that's going to happen and some value. In other words, if they send you a specific value, if a specific client ID comes in with a specific request code, you now know what it is that they want, this custom behavior they want to happen. And this way you don't have to create a set of different routes and duplicate all your code. You can still maintain the same route, you can just customize the response. So let's have a look at this. We have health URL as earlier, client ID, let's look at the prod configuration, and here we have a bunch of stuff. And here we have the token to get the access token, the doc report, like where we can get the reports, the client ID, health URL, request arrival header, which is this custom weird header they need in just to tell them when the request arrived. And here we have the request codes, which is going to have one request code right now. We could have had, like, they could have said it's going to be XML tomorrow, it's going to be JSON, like it could be tons of stuff that could be added here. One thing could be like, yeah, if it's Tuesday, and the request code is this, the system should crash. It can be anything basically. And then we have the same stuff as Google kind of had here. Cool. So here we have some routes, same deal here. They just have the same routes, like this is just a demo, but they could have had any set of routes here with custom features on top of the thing that you're actually building. And here I've created a little services directory for just my, well, this is where the services live that are specific to my bank. And here we see that they have I've created an interface for an access token, and I have this thing that I call my bank service. I've just faked this, but this is basically the thing that I was talking about. They need us to get their reports from their system because they don't post it to us. So we need to probably run this on some type of job or something like that. But in this case, we're just going to have it on request. So they're not going to send the report to us, they're just going to post a dummy request to us, and then we're going to go and get it for them, because they have multiple reports for no reason at all. And basically this is where the configuration becomes very useful, where we can just, where you can go and post to all of these different endpoints with the access token that we have been given, and then we can just resolve all those promises and return them. And then we have this little function here that goes and gets the access token. This is just dummy as an example now, but I hope you get the drift, that we have created now a service that can solve this problem of getting the reports. So if we now have a look at the flow, so what's going to happen is that we're going to go in here, and we've seen here that I've actually loaded up, I've started my bank basically. And I'm going to demo just a request here, how it could look. So here we have a request. Let's have a very verbose request here, so we can see here that I'm going to go and get the reports, and I'm just going to specify 2 arbitrary dates, and I'm including my client ID. Just going to hit that, and what I'm going to get back is an empty array, because basically we're not, like as you saw, I'm not actually returning anything. And we can see here that I have this custom header here, where I'm including this custom header here, and in the response here I see that, okay, my bank ID is containing token, and this weird header that just returns a date is there as well. So we've kind of achieved this thing that we were talking about, that alright, so they have their own permutation, we've loaded the correct routes, we know that they can go and do the health check if they wanted to. The header middleware is doing what it's supposed to be doing. You can see here, my bank, it's adding the headers as expected, all of the headers that they needed in the response. If they needed other stuff, we would have added in that as well, of course, but keeping it as generic as possible is very useful. And when we did that GET request, we hit the, let's just close this down here, services, report service, and as we can see here, I'm just including my bank services into the report service. And here we can see that processing request is just like, it's just a dummy endpoint right now. And getting reports, that's the thing that is interesting here. So we get the client ID, we get the request code, and then we check, is the client ID my bank config? If it is, then we need to do and go and get these external reports. And that's pretty much how it needs to work, right? Everybody else is gonna just go through here and like go to our database and like do the thing. I'm not implementing this code, it's just for demo purposes, but I hope you get it. Everybody else is gonna go to our internal system, but this is the deviation right here. And then we have a request code. And as we were saying, like sometimes they want it to be in base64. And so when we have gotten the reports, then we're just going to do some processing and do like all the stuff that we want. And then we're going to base64 encode it. And here is some dummy example where like getting the external reports is also something that could have multiple permutations. So we're simply going to have a case here where getting external reports is a generic thing, because it could be the fact that another bank comes and says, hey, we want this as well. And then we had another case that fits them, but you can see that the service is their actual service, which is the thing that we saw here in the client's directory. So if I now go and I do something like this, where I include, you can see here that I'm including the code for base64, and now you can see that the response is not an empty array, it's actually a base64 encoded string. So this is pretty much, as you can imagine, this is getting to be not that nice from a developer perspective. It's not nice at all, but the problem is that you cannot really get around it. You have more permutations the more customization you make, and in order to mitigate that problem, I highly encourage you to consider having this idea of a client ID and a request code or something like that, and use switch cases to just map out where in the flow you want to go. As you can see here, I've added logs for everything I'm doing, so I can very clearly follow the steps that have taken place when a request comes in. And while I can't make the code nicer, this will keep it maintainable for longer. It doesn't really matter how many permutations or how many new customers we get, because we can simply add more cases that take care of each of their individual requests without running much of a risk to infect everybody else. It would have been really bad if we went in here and put a bunch of if statements and other complicated logic, but by just keeping this concern with this, you're creating specific services that cater to these custom needs, and then just switching on where in the flow this permutation needs to take place, and using a client ID and a request code of some sort, it makes it very loosely couples everything very extremely well. Because imagine tomorrow somebody says, yeah, we want just to remove some customization, maybe they don't want this anymore. Well, then it's as easy as for us to identify the place where the base64 encoding is happening and just remove all references to this configuration and the logic that is associated with it. So what I want you to take away from this is basically that the end goal when you're doing integrations is to create a standard experience, because if you only have to deal with one single permutation of something, that is the easiest thing for you as a developer. Sadly, it's very rare that you can do this. If you need to start adding this custom behavior, I highly encourage you to create some type of isolated mindset around it. You isolate all of the madness into somewhere, and then you use a way to identify who is contacting your system, so that you can create a configuration, a runtime configuration around what the behavior should be. That runtime configuration should include all of the necessary information for the program to know what to do when an incoming request comes with that specific client ID. And if you want to go one further, you can use something like a request code to even further customize the behavior of the request and the response. Hopefully you found this useful. Have a great day.